Hello students, today we are going to start exercise 1.3. First question is to prove under root 5 is an irrational number. First of all, let us assume that under root 5 is a rational number. Therefore, under root 5 can be written as a over b, where a and b are integers and a and b are non-zero. Suppose that a and b have a common factor, other than 1. Therefore, we shall divide it with that common factor. Therefore, we get, after dividing, under root 5 is equal to p over q. What is the meaning of these two steps that we have used? Let us say I am taking a rational number 6 by 9, and when you make the factors of these two numbers, that is numerator and denominator, you will get 3 into 2 and 3 into 3, and you see 3 is a common factor between these two numbers 6 and 9. And if we assume 6 over 9 as a over b, and I am telling you, suppose that a and b have a common factor other than 1. We know that 1 is a number that is factor of every number, whether they are co-prime or composite numbers. Now we shall divide it with that common factor. Now if we divide these numbers by 3, what shall we get? We get 2 here and 3 here, and we get 2 and 3 which are co-prime. 2 and 3 are co-prime. They have no common factor other than 1. But a and b have common factor. In the same way, we can say 6 and 9 have common factor, and 2 and 3 have no common factor. So a and b have common factor. We have divided a and b with that common factor, and we get p over q, that is 2 by 3. This is just an example. For p and q are integers and p and q are non-zero, and p and q are co-primes. This is number 1. Now Therefore, now we will solve this algebraically. Under root 5q is equal to p, squaring both sides, we shall get 5q square is equal to p square. Now we can say this can be taken as 2. Therefore, p square is divisible by 5. Why? See here. If I write 10 is equal to 5 into 2, then I see that 5 and 2 are the factors of 10. 5 and 2 are the factors of 10. So 5 and 2 both will divide 10 because they are the factors of this number. In the same way, 5 and q square are the factors of p square. So p square will be divided by 5 as well as q square. But we need here only 5. We shall not take q square. We need only 5. So we will take p square is divisible by 5. And we have a rule, if the square of any number is divisible by some number, for example 6 square is divisible by 3, then that number without square is also divisible by the same number. So in this manner we shall get, if p square is divisible by 5, then p is also divisible by 5. And if p is divisible by 5, then 5 is a factor of p. If p is divisible by 5, means p is dividend and 5 is divisor. So 5 is factor of p, and we can write it as, therefore p can be written as 5 into some other number for any integer r. Now take this step as 3. Further we shall use these steps. Now putting this value of p into p is equal to 5r into, what shall we get? We get 5q square is equal to 5r square, because value of p is 5r and I have taken this value in this step, and by solving we shall get 5q square is equal to 25r square, q square is equal to 5r square. Again I have taken this step as it is. Now I shall use, that implies q square is divisible by 5, and so q is divisible by 5 by using same criteria, and this number be taken as 4. Now take 3 and 4. 3 says p is also divisible by 5. 4 says q is divisible by 5. It means from 3 and 4, what shall we get? We get 5 is common factor of P and Q. It means P and Q are not coprimes, and what we have taken, we have taken P and Q are coprimes, so it is contradiction, and our result is proved.